Hello, AI Tinkerers. Welcome to One Shot. This is a place, the global stage for AI Tinkerers, where we invite experts and leaders in Gen AI to come and share under the hood a deep dive into the technology that they built, why they built it, and how you can apply it to your projects too. Today we have Nikita from Neon Database, the founder. MemSQL, I think many people know, very successful. And Neon Database is also really successful. I think of Neon as like the Gen AI friendly serverless database.
Great.
So thanks for coming.
Excited to be here.
Tell us, what is Neon Database?
So Neon is a serverless Postgres. Initially, when we started the project, we looked around and we recognized a number of trends. The most important one is Postgres is winning. And there's so much evidence of that everywhere. There's this website called DB Engine Ranking. So if I go and pull it up here on the web, I can start taking out all the technologies down here that are, a lot smaller than Postgres. You can see Snowflake rose up quite well. And this is a logarithmic scale. Mm-hmm. And now if you look at basically the top 5, right? So Oracle is still number 1, MySQL number 2, and SQL Server number 3. But the only one that is consistently growing is Postgres.
Interesting.
Right? The other place to take a look at this is Stack Overflow survey. Now you can see in 2023, the number of professional developers choosing Postgres for new applications is 49%.
Yeah.
Right? Let's replace it with 2024. Now this link doesn't work, but you can click on databases here, databases, and then the number of professional developers choosing Postgres in 24 is close to 52%. So now Postgres added several percentage points just in 1 year.
That's
right?
Awesome.
For new applications.
And the Snowflake, isn't that a bit of a red herring because it's really different kinds of...
It's a different kind of database.
Yeah.
It is for analytics.
Yeah, if you're building applications...
If you're building an application, it's Postgres.
It's a no-brainer now.
It's Postgres, MySQL, SQL Server, a MongoDB, really. But sometimes SQLite, but it's more of an embedded database.
So I've kind of associated you guys with the Gen AI friendly database. Why do I do that? What are the things more concretely that you do?
That's right.
That you would consider to be
right. And so we started with thinking, how can we empower developers? Because at the end of the day, if you're a database provider, the persona you serve into, like this is your God. Your God is a developer, right? So you want to make them incredibly productive and incredibly kind of fluid, right? Because every context switch for a developer costs you something. So we wanted to catch developers in the moment and enable them. Then turned out, so if you over-optimize for user experience and developer experience, you actually do very, very good for Gen AI. Because Gen AI agents are basically artificial developers. And whatever works for a human actually works for AI. Now, what is this exactly? The first thing is incredibly dense APIs. So when you're generating code and you need to consume whatever technology over an API, the counterexample to that would be something like AWS, right? When you go and spin up infrastructure on AWS, that would be multiple API calls.
It's a high cognitive load.
High cognitive load. If it is a high cognitive load for a human, it's a high cognitive load for AI as well. And the reason to that, humans, even in the world where the agents are just as smart as humans are smarter, which we're not quite there, but looks like we're going to get there. The amount of context that humans have is huge.
So is the right way to think about it? Neon is open source. Neon is Postgres, but you've created this layer around at least part of what you've created.
Correct.
To make the administration, deployment, scaling, et cetera, of that really super easy.
Super easy, right? And you can, I'll give you a tweet that I did, the other day, where you can create a Postgres database in just the 3 lines of code.
And I did this yesterday, actually.
Yes.
So I got Neon. I actually took my dev database and did a table dump, and then I had it running in Neon in the cloud, and never having authenticated in less than 5 minutes.
Correct.
So it definitely was validated, and the auth step was so seamless. I thought it was
I can actually show you, right? So here's Neon CTL that is running on my laptop. You can install it, npm I neon CTL. So now you can say neon CTL auth, right? And it just goes and connects you to your browser. You click authorize, and then you're done. Thank you for using Neon.
Yep.
So now you can go back, and then you say neonctl, just say project.
Yeah.
And now
this
you
is
see
how I'm provisioning new databases for dev and production and
right.
doing the branching, which we'll get into.
You say neon project CTL projects list, and here are all the projects that you have in Neon, and each project is a database. Right. Then you go here, you see all these projects, the ones that are yours and the ones that are shared with you. Now instead of list, you say create, and then see how fast this goes. Right. Done.
Yeah.
So this thing returns you a Postgres URL that you can plug in here, and now you connect it to Postgres.
So making it super easy to make databases, great. I have like one database, but I read something on your website that one of your customers has like 100,000 data or 200,000 databases.
Correct.
It's like they decided to spin up an entire database for each customer. It's like a low-code tool.
This happens quite a bit. We're talking about Retool, which is a great company, by the way. And then there's a product called Retool DB, which creates a database on demand for their users, right? So again,
I can see right away how like that would create a lower latency user experience for each of those customers because you're able to
because you never wait, right? If you go on AWS provision a database, it takes 10 minutes,
That's
right?
cool.
And then here it comes back in a second.
Yeah.
And yes, so this is one use case. Like if you are a dev platform, whatever dev platform that might be, right?
It's interesting to think about like what you said, connecting that thought is like an agent that actually decides I'm going to go create a new database instance and populate it and use it. It's sort of the same way people are building memory into memory packages for LLMs and things like this.
Right.
Why not build a database DBA agent that does
But
this?
OLTP, which is like online transactional database, that use case does not go away.
Yeah.
But the amount of consumption, the velocity of that consumption kind of correlates with the number of applications that are being created every day. And with agents now we're entering the era of throwaway apps or instant apps.
Yes.
I can go on a product called V0, right? And I can say, create a mortgage calculator.
Sure.
And this thing will go and create a mortgage calculator on demand. Now this is just JavaScript, and see that now it's generating it, and then it's going to start giving you a UI preview, right? Let's switch to the UI preview, and you can see that it's coming out, right? It's like you witness in a new application being born. And then you can go and chat with it and say, okay, well, why wouldn't you add, some tax calculations to it and tax savings and whatnot? But like, boom, like I just created a mortgage calculator. My wife can create a mortgage calculator who is a little bit technical, but not really. She's not a professional developer.
And so you're saying with the knowledge that I can go create provision databases, then we can create persistence for these apps too.
Correct.
And we just
and Replit already does it. So I think one of the most exciting things that happened in the agent world was first the arrival of Devin, right? This Devin software engineer, and the whole world was like, wow, and it's like, oh my God, this actually is possible, right? That was more of a vision. And then Replit allows you to create small apps on demand. And many times, so the interesting observation is the mortgage calculator that I created on demand has better user experience than going and Googling and trying to get a mortgage calculator on the internet, because of course, when you go there, they try to sell you mortgage rather than give you a calculator.
Well, okay, so if I was going to go provision in a disposable software kind of way, a database for my whatever, like let's say I have a business, small business, and I've got like documents. I'm like, great, agent, go slurping all the PDFs. And oh, by the way, index them using this RAG thing I heard about. And, it's going to go off and use your tools. How quick is it to do that? It depends how much you have, but like how fast is the database piece of that? Is it?
You're talking about RAG. Oftentimes, if you like, I want to chat with my PDF and I want to do semantic searches in my documents. Typically, you can go with a various degree of fanciness here. And the most basic way is you're going to go chunk your documents. You usually chunk your documents with a model as well, and not just kind of blindly, 8 kilobyte chunks or and whatnot. Then you embed them, and then you need a vector store. So you need something that gives you what is called similarity search.
I mean, you have PG vector support, and you're a core contributor to that project.
Correct.
So, but do you wrap any of the work you just described? Like, I got to chunk, I got to feed it. Maybe you want to do contextual chunking, like the Anthropic just talked about.
Yes.
You want to do things that are more like data prep, but not application. So I would rather, as an application developer, have that be abstracted. Do you do any of that? Yeah.
So far, we just give you PG vector.
Okay.
We are looking. So we've built on a hackathon a month ago
Yeah.
a project that we call PG RAG.
Mm-hmm.
We're still debating that internally. Is like,
Product
is this in our corner
Right.
or is it in the
Sure.
kind of like ecosystem corner?
Right.
But there's a project that we built that's called PG RAG that automates a bunch of stuff.
Okay.
There's a that,
And I
there's a-
imagine you're putting those into like cookbooks that people can reference and
cookbooks are already there.
Yeah,
There's tons of
yeah, I
templates
saw
that,
that.
explain how to do that, and there are many ways to
Yeah.
do that. Right? There's LangChain, there's
Yeah.
Llama Index, there's tons of things.
'Cause I think about like, I mean, we have to talk about RAG even though it's so boring.
Yes.
but it's such a popular use case and so important. And there's still work to be done to make it. I was really excited. I don't know if you saw the contextual retrieval blog post that Anthropic put out where they talk about combining like keyword search with embedding search and why putting those together. And then they did some, I think, data prep stuff on how do you embed your chunks with context. And they showed in a kind of scientific, measured analytical approach that it performed much better than any other approach, right?
Right.
But I can just imagine, like, as a user of a data store, I want all of that just abstracted for me. So whether it's a cookbook or a feature, at least I'll be your first customer.
I think maybe future it looks
Yeah.
the way you're describing. As of today, the simple stuff is trivial, right?
Yeah.
Chunk the document, put it in the vector store, take a cookbook, apply the cookbook. I'm like, I can go and start applying that. So I can go on GitHub, PG vector, and then there's a database that we just created in my CLI. So it's right here, and I can go and start like literally applying those commands. Create extension vector.
Okay.
Go here. This is the database we just created. Go here, create extension vector. It works. And then, one by one, you go through a cookbook. Of course, you can like follow. Anybody can do that. Then a query comes in. You embed the query itself. Then go into the vector store, pull out all the chunks of the documents that are relevant there by doing a similarity search, take them, put them in the context window, ask a question to LLM. So you do a little bit of prompting, and you do a little bit of this vector embedding thing, and that is trivial.
Yeah.
Now, from there, you're right. If you want to increase the quality, you care about ranking. And so now you have re-ranking models.
Yeah.
2, now you're realizing that certain re-ranking models should be trained on your data in addition to just taking them all off the shelf. The second thing you're realizing that, keyword search is still a thing. And then you kind of need to combine keyword search and vector search. And the third thing that you realize that there is call it a graph RAG use case. So I'm going to graph RAG Microsoft. Microsoft launched this just recently, which is a modular graph retrieval thing. And so people who increase the quality, and those are kind of advanced companies now, such as like Glean, they all have graph semantic search in addition to this. Now, what you're asking is, well, that sounds complicated, right?
It's fun to tinker with, honestly. And I mean, part of me is like devil's advocate is like, one is I do want a product, just make it go away. I want to focus on my app. Maybe that wins out actually. But on the other hand, like if I jump into a product, then I'm locked into how they've implemented it. And this stuff is changing so fast, with the keyword search plus, I mean, we're a year and a half into RAG and there's already big improvements on quality based on these techniques.
100%.
And then you add in graph and you add in more. And maybe the right approach is not a product, but it's like, the agent figures it out and evolves over time.
It could be. Well, typically, if you look at the history of technology, first of all, you enable use cases. And then you simplify consumption. And so even if you take, my favorite subjects, relational databases, that's like a, 40-year-old industry or something like this. Well, the consumption in the beginning was really hard. And then over time, we make it easier. But the core foundation of the technology we figured out years ago. So now we're iterating on DevX, we're iterating on simplicity, we're iterating on like making stuff done in seconds rather than in the past days and hours and whatnot.
Let's talk about branching because that's something that blew my mind and I'd not heard of. I've been using databases forever, and you talk about an instant branch of your database with every pull request. You talk about going back to any point in time or any second or minute. Why would I need that? And it sounds awesome. How did you make that happen? And what are people using that for? My guess was like agentic workflows might be doing destructive things to your database. So why not quickly branch,
Yeah,
work there, get a result, and then roll back? Or
yeah, you want breadcrumbs. So
Okay.
like jumping straight to agentic, you want
Yeah.
breadcrumbs.
Okay.
So for example, well, today most
What is a
agents,
breadcrumb?
it means that you want to go to the previous state,
Okay.
whatever that state was.
Okay.
And the reason to that is agent made destructive changes to your database.
It may drop tables.
The second, it may drop tables, it can change data, whatever. The second reason you're testing.
Yeah.
So, and if agent produces some code, the agent generates tests just like a human, and you want to branch and run all the tests. And tests typically not just reads, they reads and writes.
Yeah.
So you don't want to apply writes into your production database. Finally, you sometimes want to do things in parallel. So I think most of agents today are single-threaded.
Yeah.
And there was a tweet of Harrison Chase and Michelle Costanza, I think that's his last name. He is the chief of AI, head of AI at Replit. And that's the guy behind Replit Agent. And what they were talking about is most agents are single-threaded. They do one step, and then they do another step, and then they do another step. You can imagine the world that you do those things in parallel. If you want to do those things in parallel, you want to fork your state. Because agents operate on the state, and databases that state, and potentially your files or file system or S3 state. Those are all your states. And if you want to explore anything, like one of the best things that you can do as an agent is to build the same feature 10 times.
Yeah.
And then choose the one that is better. And of course, you're bumping into inference costs, you're bumping into the infrastructure costs, and you're bumping into just the time to do that. And I think all of those things are going to be solved. First, the inference cost is rapidly depreciating by, I think, like 30x, 5x a year or something like this. It's incredible. Neon already allows you to fork the database state. We don't do it for the file system state. For the database states, we can do it.
And what's a concrete example of where branching is necessary for an agent system? Like what would be a use case where it's like super powerful?
First of all, is that parallel Monte Carlo tree search.
Okay, and what's the scenario where if you didn't have that, it would break or it'd be a problem?
Oh, it wouldn't break. It would just take a lot longer. So because you do things in parallel, right?
But you could do things in parallel without branching and just use the same data set. Why not?
Well, but if you change the data set, right, and then each implementation of what you're trying to do in parallel, you need to start from the same.
I guess I'm thinking of the scenario I'm thinking of is multi-agent where they act sort of like humans in different roles. And I'm thinking about like factory production where the manager agent is overseeing and maybe they intervene, in which case you'd want the data to be changing.
Okay, yeah. So we are talking about two different things.
Okay.
I'm talking about an AI agent, software agent that is building software. And if a piece of software is built, and always every piece of software almost needs a database. And if you build the next feature to that piece of software, as in AI, what is called SWE agent or a software agent, then you want to fork the state and then kind of explore the state, because in this particular case, an AI agent is a software developer.
Oh, you're just saying, okay, you software development agents that wants to try a bunch of scenarios. You want to do them in parallel on your data.
That's
basically just copying your database so that they each are running independently. I get it.
Yeah.
Okay,
so that scenario makes sense, right?
Are people doing that to create systems that'll create better? I guess they must be when you're people exploring disposable software. I guess there's low code, no code, and there's autonomous something. And in that space, to offer better results to customers, you want to do things in parallel. I mean, the dream scenario is like I spec it, and tomorrow morning I have 5 versions of the product I just choose.
And at least the promise of this is Devin from Cognition Labs. So you spec it. Of course, there should be accuracy in the specking. And then if there are inaccuracies, the agent will go and clarify it with you and ask questions. And then
this doesn't happen with humans because it's too slow and expensive. But if you give me there's 2 cases of a vague spec. One is like stop and wait for the PM to get back to you.
Right.
And the other is like let's invent 10 versions that one of them is probably the right interpretation.
Correct, right? Yeah,
that's better.
In the world where you're working with a human, a human will either have to make assumptions, or interact with a PM. In the world of agents, you can make many assumptions in parallel, and then you build it, and then you choose it. So one observation that I make, that when you build software today, one person it's always a pair, right? One person is writing the code, the other person is reviewing the code. And I think as we switch into the agentic world, we're going to be in the situation where one person is writing the code, and that person could be an agent, and a human is reviewing the app, not the code. And there should be feedback mechanisms between reviewing the app and then feeding that information back into the agent. if you look at where the dev platforms are heading, and I'm talking about Vercel specifically, and I think Netlify might have this feature as well, but we're working much closer with Vercel. They have this notion of previews. That every pull request that you send generates a full version of the app, the whole preview. And then you can go on consume it. It has a Vercel toolbar that allows you to comment on the site. All that information goes straight back into the agent.
Yeah, right? So you could ship faster and test broken stuff.
Right. You can point and say, fix
you
this.
Remove risk.
You remove risk.
Yeah.
And that's the. I think that there's going to be that.
And if
step.
if you're not using this branching thing, like what a pain! It takes me like 7 minutes to restore a full backup of my database right now.
Correct.
You know, I'm not going to spin up 10 of those every time I run.
And let me just show you, right? Let me just show you.
But how does it work? Is that a native feature of Postgres or something?
That's not a native feature.
You've built it in.
We've built it.
Or
okay, let me explain how to do it. Let me show this feature, right?
Okay.
So I'm going to go here on the SQL editor, and then I say, create table T ID int, just like the most basic table. And then I'm going to say insert into key values 1, 2, 3. Right. So I added a few, and now I can go into the tables view and I see, couple instances of 1, 2, 3. Then I can go to branches and I say, I want to have a new branch. And I'm going to call this branch AI Tinkers. Right. And when I created this new branch, which happens instantly, and it happens instantly when the database is small, and it happens instantly when the database is large.
Amazing.
And then I'll explain why. So now I can switch between main, and I can say
instantly, and I can go operate on the new branch
independently as well. So
I don't believe you.
It's a sandbox. Yes.
How?
So I go from main, and I can go on AI Tinkers, and now the data is the same.
Okay.
So some databases out there, they say, oh, we have branching, but all they do is create a new database and copy the schema.
Yeah, of course, that's
easy.
the easy approach. But
here's how this works.
Is this a secret you're never going to reveal? Like,
the code's open source.
Oh, okay, even for this.
Even for this. Yeah.
Oh, wow.
The code's open source under the Apache license. So there are no secrets. There's just engineering.
Oh, that's amazing.
And here, if you click on architecture, neon architecture.
Yeah.
There's the simple architecture diagram with a lot of engineering behind it. So here you have Postgres, and this is storage. So let's for a second assume that this storage looks more like a Colossus file system, just a gigantic file system.
Okay.
It's not really, because the API to the file to the storage subsystem is different. That API is very Postgres centric.
Yeah.
But what it really is it's a storage system that is built. It's one shared system that's built for the whole fleet of Postgres instances.
Was
and we run close to
this part of Postgres already, or is this an innovation that you've
this is innovation we've done.
Okay.
We built it from scratch.
That's what enables
we
it.
built it in Rust.
And you're compatible with whatever low-level Postgres APIs are there.
Correct. And low-level Postgres APIs are, there's this thing that's called wall, write-ahead log, and it allows us to ingest the wall. And then there's another API that allows us to fetch pages. So it talks to Postgres in a very low-level thing, like give me an 8 kilobyte page. Now, when you say I want to create a branch, we go to this storage subsystem and say, hey, create a branch, and it moves a bunch of pointers inside of it and uses what is called copy and write. So the actual physical pages that represent that state for the database are not duplicated.
Got it.
So, but some pages know that they participate in this database and in that database.
Got it.
And then what copy and write is, and that's why it's so fast. The database could be a terabyte, could be 10 terabytes. The branch will be created instantly because it's just a little bit of metadata.
Sure.
Everything is also integrated with the object store. And I think object stores are so good these days that every single database or data infrastructure will be built on the object store over time. And now it's like, this is the time to do it for operational databases as well. You still need a low latency tier that sits on top, but it's like a big part of the whole architecture.
Storing data, do you have anything interfacing with or used with edge clouds, or to getting your data closer to where people are? And how does that work? I know when I signed up, I chose one location that was closest to my app. But do you have something more?
That is actually quite a hard problem.
Okay.
That is quite a hard problem. We do things a little bit better for you. And I'll show you, there's this thing called Neon Serverless Driver.
Okay.
serverless npm. So it's downloaded about 200, close to 200 downloads a week.
Oh, yeah.
What that allows you to do is, if you are in any edge location, which could be a browser, which could be a Cloudflare worker, it could be a Vercel function, you can go and make an HTTP request into the database and get the results back. Now, databases are kind of stuck in the past. They require you to have a stateful TCP connection to them. And what stateful means is like all the temp tables, all the transaction context, all of this, and databases are transactional. You need to tell, change some data, commit or roll back. Now, developers today, they like to live in the world of TypeScript or JavaScript. And so that maps very, very nicely. And you can make an HTTP request. Believe it or not, that databases of the past assumed that the application sits closer to the database. And therefore, if you have a chatty protocol, it almost doesn't matter, because the cost of the transaction is not very high and it's kind of much higher than the cost of the network round trips when you sit right next to it. And that is actually true if you sit right next to it, but it's not longer the case. And so now the cost of each round trip could be much higher. So this is what we do for edge functions and serverless functions. Plus, we can create read replicas, and we're very friendly with all the caches like Cloudflare, Hyperdrive, and whatnot. And the popularity of this thing shows both the performance gains that you can have, and then the convenience. The other thing that is kind of cool is this allows us to bring more and more functionality in this serverless driver. And the next one that's coming is called Authorize. You can go here to, let's take this project called Azure. By the way, Azure launched today at the time of the recording. Now we can spin up databases in Azure.
So awesome.
There's this Authorize page, which right now only visible to me, so only visible to Neon employees. And then you can go and add an authentication provider. And now if you're building an app, that has Auth, and you use, let's just say you use Clerk, because developers, that's like the Auth, the awesome company for Auth today. Auth0 is like an awesome company of slightly yesterday. And then Azure AD, for example, now that we have Azure, we integrate with Azure Active Directory. But each of them, all they do is when you authenticate, when you click on this button, I call authenticate with Google or something, or Apple or GitHub, whatever, what they send you is what is called JWT token. And then you can go and connect those things together. I can need to log into Clerk.
And so you're making that world play nice with the database world with this product. This is not launched yet.
This is not
launching at the end of the month.
This is going to launch in the end of the month.
So this is we'll announce this video when this is ready to talk about.
Correct.
And that is really interesting, because you see this evolution in how software is created, where it's composable and disposable.
Correct.
And
it's composable,
therefore allowing
it's
you're going to go from spec to implementation, but still use rock solid components in the background. Versus today, the disposable software is a joke right now. It's a funny little JavaScript app, but it's not real. But with these, it could be real.
Yes, and then you don't need to do with Neon, for example, you don't need to make that weird trade-off. That it's either good for developers or it's like robust and great infrastructure. Now it's both. And so, for example, if you think about Heroku, right? Heroku was a pioneer of developer experience. By the way, a bunch of people from Heroku went to GitHub and made GitHub great. And then they continue, innovating in that journey. We have some people from GitHub as well. But that was that trade-off. It's nice, it's convenient, but it only scales up to a point. And from that point, you need to eject. You need to graduate.
If you grew out of Heroku, you had a good problem to have. No way, but it's still a problem.
But it's still a problem. And then you go and invest, and you build a DevOps team, and you go on AWS.
Well, people complain now about serverless. There's a whole generation of developers that, let's call it, they don't have the bare metal experience of building servers and architectures, and they're getting into it with how they get into it, and it's great, and they use serverless, and then you see the tweets that are like, oh my god, I have a $2,000 bill, what do I do? I'm begging for help here publicly.
But with Neon,
is that a fundamental problem with this architecture? Why?
It's not. And the reason to that is it could be. With Neon, it's not quite yet, but we're on a journey. But it could be strictly better. And what makes it strictly better is that if you think about how we charge, for example. We
Yeah.
charge on this thing called compute unit,
Yeah.
which corresponds to 1 CPU
Sure.
and 4 gigabytes of RAM.
Yeah.
And
Well, feedback. I had a trouble understanding that myself.
Right.
I'm like, I run a Postgres database in a cloud. I rent the server. It's a fixed cost per month. Every once in a while, I want more speed or RAM or whatever because I grow my data set. And I just click a button and I upgrade. That's how I do it. It's pretty old school.
Right.
When I go to your thing, I'm like, oh, this is interesting. My questions are sort of fundamentally like, if I move my workloads over, will it be faster or slower? I think maybe faster. These guys, and they auto scale, that would probably be useful. How useful? But then on the pricing, the tier 1 paid plan is like half the months of hours. Like, are you counting hours when a query runs, or is it me saying the machine's live?
Right.
My machine's live 24/7.
Machine's live. But
Okay.
the size of that machine is dynamic.
Okay.
And
So
by the way-
I need a plan because I have a database that runs 24/7 all month.
Correct.
I need a plan that has at least those hours.
Right. But
Is that how to think about it?
The way to think about it
Yeah.
is like when you go on Amazon and you
Yeah.
say, and you choose that size and it's
Yeah.
a manual operation, that gives you the cost of your database is, a fixed line that goes like this.
Right.
And basically it's like this,
Sure.
that
Whether
rectangle.
you use it or not.
When you're using,
Yeah.
you provision it for
Sure.
peak, right?
Yeah.
And then for Neon, it's going to be the area under the curve.
Okay.
And the height of each curve is how much database you need to have each second.
If I'm scaling up that moment.
If you're scaling up
Whatever.
in that moment. And we're listening to all the telemetry that's coming
Got
into this compute instance that is right here.
Do you have a tool to help me predict what that cost might be before I use
We
it?
can
or
tell you,
estimate it, or-
we can tell you.
Like, can I export my SQL logs to you and just you tell me today, Joe?
It's hard to do it ahead of time,
something?
but we give you all the historical data.
Got it, okay.
So now you can go back and
start
see
using
how
it.
many compute units you had on a per second basis. And actually, the price is very, very competitive
Yeah.
with Amazon. So if you just say,
Yeah.
okay, I don't want to change
Got
my
it.
compute size at all,
Yeah.
right? I'm just going to have fixed compute. This
Yeah.
will match your RDS or.
I mean, given how lightweight it was, and like I tooled up and I actually got a database table running in it in the cloud like in 5 minutes. I was like, okay, the next step for me would be it's so ephemeral. Why not just do it? Load my 8 gigs in there, swap my app over for a while and run it and see how the performance is.
You can do
If
that
I don't
too.
like it, I just dispose of the whole thing.
Correct.
But if I'm better off, I'm better off.
That's right. Yeah. And Postgres to Postgres, well, that's the beauty of it. Postgres
Yeah.
to Postgres migrates very, very easily.
Yes, of course.
And if you have
Yeah.
an RDS instance,
Yeah.
you can move it. We actually.
And my calculus is so short term around the price and performance when I know in my heart if I'm successful, I need to be here. I need the manageability.
Correct. Yeah.
I don't want to hire. How much did DBA cost?
Well, it's just $200,000 a year, right? I mean, unless you outsource this thing somewhere
Yes.
else. But
Yeah.
you would rather outsource it to a dev tool
Yeah.
because, well, tooling is less expensive, or outsource it to some sort of an agent.
So talk more about auto scaling for a minute. Like, how quickly does it spike? Does it scale up? Like, I do, AI Tinkers, we do events, or we do like, let's say, and you get a ton of people
few
signing
seconds.
up all at once,
Few
to stay
seconds,
in and
few
out.
seconds.
Okay. In a few seconds, it would actually accommodate an incremental load.
Correct.
Wow. Okay.
So it happens really, really quickly.
Okay.
We actually scale up much faster.
And that's because you separated this data store architecture from
The only reason
running
to
in-
deliver on serverless
Yeah.
is to separate storage and compute.
Yes.
Because that's what makes
Yes.
Postgres itself, in a way, stateless.
Okay.
And when it makes it stateless, we can change the size of the VM dynamically. Now,
Okay.
there's still a lot of system engineering that goes into like, hey, I thought I had this much memory, but now I have
Yeah.
this much memory.
Yeah.
So Postgres needs to be ready and not crash
Yeah.
when this happens.
Yeah.
And so it required some changes, and
Okay.
we can go into like the long systems rabbit hole of how that's done.
But this makes sense. So if I'm using Postgres on my own or through, I imagine, many cloud things that don't have this architecture, then I'm not going to get those kind of.
You're not going to get serverless.
What are the? But you mentioned Aurora earlier when we were talking, as you started as sort of like an open source or alternative to
Aurora. Yeah.
and it's evolved from there. Like, in what? So do they fundamentally have a similar like separation of storage and compute?
They
or
do,
is it different
right?
architecture?
I think that was, and again, they're not even
They're
the first one
innovative. Yeah, sure.
to create it, but they were the first one who did it for OLTP in the cloud,
Yeah.
right? The previous technology that had that architecture is actually Oracle RAC.
Got it.
So we're
Yeah.
basically recycling lots and lots of ideas.
Sure. Okay.
But we're building it for the modern
Is
consumption.
Snowflake fundamentally under the hood something like that too? That's how they're
Just for analytics.
to take
Just for analytics.
bigger-
So for Snowflake, you don't need to have super low latency storage because that's needs for applications and transactional workloads.
Okay.
But fundamentally, Snowflake stores data on the object
Yeah.
store. And when my earlier comment that everything is coming to the object store,
Okay.
this is actually true.
All right, let's do some rapid fire more style questions. So you've raised how much money? This company?
I think it's now 132 million.
132 million, just a little of a chunk change. And you're the CEO and founder.
Correct.
Deep database background, obviously very technical. It's great. You probably shouldn't be tinkering, but what are you tinkering on right now? What are your side projects?
My side projects are all agentic right now.
Yeah.
So I'm tinkering with Sui agents.
Okay.
I'm tinkering with like, you know, I have access to Devin.
Yeah.
So I'm like playing with Devin.
Sure.
I think
If you're building an agent system on your own, are you just doing it off the cuff or are you using any of the frameworks that are there? There's lots of frameworks.
So yeah, lots of frameworks now, and like LangChain and Llama Index and all
Are you
those things.
using any of those, or are you just doing stuff?
I'm using LangChain.
You're okay.
Yes.
Yeah.
And so but the lens that I'm looking at all that is all Sui agents. I think Sui agents is absolutely the future, and we are approaching.
Define it, lay it out. What do you mean by that? Sweet agents.
Sui.
Sui agents. Sorry.
Sui means SWE.
Got it.
I think people mostly
Yeah,
call them Sui
yeah,
rather
okay,
than
got it.
SWE.
I never heard that pronounced, so.
Anyway, software. It says software agent, right?
Yeah.
But like, look at all the angles that we're approaching.
Yeah.
The job of accelerating software development.
Is your angle just playing and it's fun, it's play, tinkering, or are you trying to do something that you can use in your company, or are your approach is like looking at the benchmark and seeing if you can beat it? What is your angle?
So
I'm just curious.
So I think that I'm a firm believer that software agents will change the way we build software.
Yeah.
And when this happens, the whole infrastructure underneath will have to adapt.
Sure.
Or change, or new ones will new pieces of infrastructure will be created. So when it comes down to new pieces of infrastructure, we already know that we need evals.
Yeah.
And we need eval stores, and therefore companies like Brain Trust Data and Linksmith and all those things. So it's just like system of record for evals.
Yeah.
We need to track evals. We need to generate evals as well.
Yeah.
So there are tools now that can come to your code base, and you obviously, like as an owner of the code base, are wondering, right? Is this agent going to work on my code base?
Yeah.
So for that, you need to generate a bunch of evals on your code base. So there are tools now that can help you with that. As the agent goes and start crunching, you know, there's a certain amount of context window, you know, size, which keeps increasing, but like still in the hundreds of thousands right now for Anthropic, for Claude, and Claude is the best LLM for agents right now, which may change any moment.
Yep.
Then you need a memory tier.
Yep.
So you need a memory tier. So that is a new piece of infrastructure.
Sure.
And I'm kind of like playing with companies like MemZero and Letta, seeing what they're up to. That seems more like an OLTP use case. The idea there is like you can.
MemZero is the Palo Alto AI Tinkerers organizer.
Oh yeah. So the idea there is you can tell LLM that they can an LLM itself can offload certain information into the memory and request that on demand as well. Yeah, which is kind of cool.
I can imagine that's interesting if you're a database guy to look at that. It's the future, and it's going to create a lot of workloads.
But all of that is infrastructure. When I think about code interpreting, right? So you had E2B on your podcast recently, and then Perplexity is using them. Then when you just do function calling, then this is next gen infrastructure.
Sure.
Can you use AWS Lambda for this? Yes. Is it custom built for that use case? No.
Oh, it existed 10 years before any of this stuff.
Right. Can you use dev containers for that? Sure. Yes, some people do, but there's new requirements that are coming in.
Okay.
So I think this whole infrastructure pyramid, starting from storage, compute, database, and then higher level instances of infrastructure, and some of that infrastructure I want to bring into the Neon platform. Okay. Just like I brought in Auth, right? Just like we will bring API, data API into the platform. Okay. We may bring memory.
So tinkering, because there's some extremely interesting value there that could be part of your platform. What are today's use cases you see on top of your platform that are GenAI or maybe even Sui that are like, I asked two questions. One is like the boring high scale use cases. I always like, people are tinkering, but what is really taking off in your opinion that may be boring and high scale? And then the second question will be, what's the most exciting, outlandish, crazy, but it might work?
So the first use case that came in was extremely boring. I need a Postgres database. What is the simplest thing in the world that can give me a Postgres database?
Just data from my GenAI app, simple.
Not even GenAI app.
Oh, just
any app.
Okay.
I need a Postgres database, right? Yeah, people need Postgres database.
And specifically, what are they using your GenAI friendly cloud serverless database for in GenAI world?
In the GenAI world, well, hold that thought for a second.
Okay.
Let me give you the whole progression. First, the first one was like, I just want a database, and I want a database that if I spin up does not cost me anything if I don't use it.
Sure.
So that's where the serverless piece comes in. The second use case came in as a function of the first one, which is I happen to have a lot of databases. Either I'm a dev platform like Retool, or I'm creating a database per tenant. And many customers, I need to have some sort of boundaries around each one of their data stores. Lots of reasons for that. So it's called database per tenant. So now we have dev platforms using Neon, but we also have companies that the end app using one database per tenant.
Makes sense.
Then first GenAI use case came in. It's like, I need a RAG. So the whole industry was obsessed about building RAGs. Now you're saying, well, RAGs are boring, right? How long has it been? Less than a year, right?
They're not going away.
They're not going away.
Actually, pretty exciting improvements all the time. But
they're kind of like figured out, right? Then the next use case came in is like, okay, I'm generating an app. I need to host it somewhere, and all the infrastructure is fairly easy except for the database, right? And so, and then if I'm generating lots and lots of apps, that serverless piece and the cost optimization comes very handy because some of the apps that throw away, you don't want to pay fixed costs for each database that you create because that adds up very, very quickly. Today, we're launching close like 6,000 databases per day.
Wow.
So now imagine that is, the cheapest database on AWS, like $10 a month. Like doesn't sound like a lot. Multiply by 6,000, 60,000 a day.
Incremental, sure.
Incremental, multiply that by a month.
And it's a fairly sticky thing, your database. Well, in the new world of ages, it may not be, but traditionally it is.
Traditionally is, right? And if the database works, people don't like to swap it. If it doesn't work, they get livid. Right, they just got very, very frustrated, and that's where the foundation of like
moving databases is scary. There's character encoding things and different indexes and things like. Especially,
Postgres
is good.
Postgres is easy. So once you commit to Postgres, I think switching providers is okay.
Okay, so what are some of the most exciting, interesting customer use cases you've seen? Or tinkers that are building on your platform? What are the apps you've seen that inspire you?
I think Replit Agent is probably still the most exciting thing that we have. There's a company called Wordware, which is the hottest company in the Y Combinator batch that is using Ian right now. And then I'm excited to add Auth because the moment I add Auth, which is now in 30 days or so, we simplify the work for agents, and we simplify the work for humans. And we're gonna have more and more software agents choosing Neon.
How did you first hear about AI tinkerers? Curious.
I got invited. That was Nat Friedman and Alex.
Alex Gravely.
So they organized one in San Francisco. So I came in, I showcased our vector implementation. Awesome. At that time, PG Vector was not good, meaning it used an outdated algorithm for similarity search. And we saw this as an opportunity. We built, a modern, what is called HNSW implementation, showcase that people loved it. This thing took off. 2 months later, PG Vector added HNSW, and we decided that it's much better for us and for the community to start contributing. And we took all the learnings that we had from PG embedding, such as parallel index build, we brought them into PG Vector. So that was my first exposure to AI tinkers. I came to the Seattle one once.
I saw.
I was in town. So that was cool.
You were one of the demos.
I was one of the demos. I think we're ready, especially after the 30th, to show a few more. So I'd be excited to come either in Seattle or in San Francisco.
It'd be fun. We could do, and obviously you were a sponsor of our hackathon we just had.
That's right.
Thank you very much. That was amazing. And people did use your product. So it was a success. So where can people check out the product? Obviously neon.tech, and there's tons of cookbooks. And like I said, you can get started in 5 minutes if you just want to kick the tires.
Correct. Yeah.
Pretty cool.
Yeah. I think that's the best. I think you can also consume it via Vercel. You can also consume it via
Replit Agent.
You can consume it via Retool now. Your audience probably doesn't use Retool because
you might already be using Neon and not know it.
you might be, if you use Replit, Retool, Vercel.
Okay, well, thanks, Nikita, for coming on and having this conversation and showing us under the hood.
Thank you for all the questions.
Thank you.